Let's go into this overview of cloud computing and talk about some of the fundamental concepts of cloud computing. Well, to start with, there are three main aspects of cloud computing. This ability to use infinite compute resources. So in practice, it's not really infinite, but it's close to infinite. So this means things like your CPU, your disk, the network. You really have the ability to scale these up to thousands and tens of thousands of instances or gigabytes or terabytes, and you don't have to worry about physically buying those. You also don't need to worry about paying, let's say, $1 million to buy a bunch of hardware. You buy it on demand. So you use it when you need it, and then when you're done with it, you can turn it back off. And so this concept as well of you pay for it when you need it is a lot like the heater in your house or the air conditioner in your house. When it gets hot outside, you can turn it on. If for some reason you want your bill to be lower, you can also turn it off. You don't have to use that resource, but just like utility, you can choose how much you use and when you use it. Let's say it's a truck. You could fill your truck up with gas and maybe you use that truck to go somewhere and do some work. The same thing applies. You don't necessarily have to buy thousands of gallons of fuel. You can go to the gas station and just get as much as you need for the particular job you're on. So really this infinite compute, no upfront investment, and pay as you need is a fundamental part of cloud computing. Some other advantages of cloud computing are that it allows you to trade this upfront cost for a variable cost. So again, think about a vehicle. So you could purchase a very expensive Tesla for $100,000, or you could rent it for one day. And the costs are very different because maybe you just need that Tesla for one day and you don't need to purchase a $100,000 Tesla. The same goes with a server. You may just need a server for an hour, but you need to use a server that has a very specialized GPU. You also have this concept of economies of scale here, where if you go to Walmart or Costco, you can buy a gigantic selection of food or a pallet of water, for example, and you don't pay as much because you're using their purchasing power because they purchase so many things they can get it for a lower cost. Another thing that used to happen in the old days was you would buy a bunch of servers. And it turns out in many cases, you wouldn't need those servers. So now what do? You spent $50,000 for a website and nobody's going to your website. So that capacity planning risk has been eliminated. Likewise, when Twitter was first starting out, they had their own physical data center and they had huge capacity problems and they didn't have enough capacity and they had software that needed to be fixed. So there's many problems both in terms of buying too much or buying too little when you have to plan the capacity for yourself. Also, the cloud increases your ability to move quicker. So you don't have to worry as much about things that are maybe outside of your area of expertise. You can focus on the business logic. Finally, when you're dealing with a partner that's an expert, it's going to reduce your costs. So there's certain fees that you don't have to pay anymore. You don't have to buy certain hardware. You also don't need to pay for specialized workers that maybe are experts in the cloud or experts in storage. Those storage experts are actually being hired instead by AWS. Finally, you have access to global infrastructure. So from day one, you can set up a data center in the United States, a data center in Europe, and a data center in Australia, and all three of those can connect, and you don't have to go physically create locations in those parts of the world. Some of the disadvantages, though, so let's not only talk about the advantages. Some of the disadvantages are that it's possible that your service has now gone down because you're reliant on the cloud provider. So we even see this in the United States with California, right? There's the PG&E utility company, and everyone gets their power through that utility company, but that utility company has blackouts every once in a while. So there is some risk when you centralize that centralized service will go offline. Also lock-in, right? So what happens if in the future one of these cloud providers decides that they want to raise the prices? Well, you're locked in and you're going to have to make a decision about that. So that's one of the risks that you take on when you go to the cloud. Also, again, some of the other advantages, uh, are not as apparent, but they can be factored in when you think about increased agility, reduced costs, access to global infrastructure. What happens when that lock-in becomes available and you don't need to use that cloud resource anymore? You'd like to do it yourself. So you now have to choose. Maybe those advantages are now disadvantages. So let's talk about some key cloud terminology here that will come up over and over again, both in exams and also in just working with the cloud. HA is an acronym that stands for highly available. What this means is that you have an architecture set up potentially behind a load balancer. Amazon has one called ELB, and it distributes the requests so that no matter what happens, you're able to get some request to go through to some web server. It may not be the same web server, it may be A, B, or C, but you can distribute that highly available web service. Another one is fault tolerance. In the same situation here, let's say that the A server has some kind of a disk problem and it goes offline. Well, in a fault tolerant scenario, it doesn't matter. The load balancer recognizes that the A web service is actually not available, and it just routes the traffic to B and it routes the traffic to C. So fault tolerance is a key characteristic that will come up again and again with the cloud. Also scalability. So this happens a lot where, let's say you're initially dealing with 10,000 customers, but then it turns out that your company is becoming very successful and this is a good thing, but you had a database that only supported 10,000 customers. Let's say it's a 16 core database. Well, what if you need lots and lots more CPU? Well, that's where scalability comes in. You can, with Amazon, say, I want a 128 core machine, and you push a button and 10 minutes later, your new database server is provisioned and automatically the traffic goes over to that new database server. So that's a huge aspect of the cloud that if you haven't done computing or built software before the cloud, these were really significant problems. But now you can literally push a button and get a larger size. And finally, elasticity does have some correlation with these other terms, but what it means is that not only can you go up, so in the case of let's say temporarily you have 10,000 customers right now, but then tomorrow for an hour, you're going to have 100,000 customers. And then the next hour after your peak traffic, you're only going to have 10,000 customers again. How do you actually spin up more machines temporarily just for that 1 hour? Maybe you have 4 more that you spin up. And then when the traffic goes back down, you want to subtract those 4 machines because you only want to have those servers allocated when you need them. That's called elasticity. And so it means that not only can you scale up, but you can scale down, and it happens in a timely fashion so that by the time the scale up happens, you're actually able to address the problem. If you're not able to address the problem quickly enough, it's not elastic, right? It's you may be able to scale, but you can't scale in the time that you actually need it. Now, let's talk about some other advantages of cloud computing here is that you're able to trade that upfront cost for variable cost. So what this means in practice is that in the old days, you would have to purchase, let's say, $1 million of servers, and now you can just make that go away. And instead, you can say, I want to spend, let's say, $1,000 per month on servers. And so you've changed the way that you spend your money in your company. You don't have to maybe get a loan to pay for those resources. And again, what that does is it makes the upfront investment go away. So that really changes the nature of how companies work, and that you don't have to be thinking about how much money am I going to pay for some upfront investment. It's very different than if you wanted to be, let's say, a work at a construction company, right? Let's say you wanted to build your own construction company. You're going to have to purchase trucks. You're going to have to purchase big tractors. You're going to have to purchase supplies, right? And so maybe the upfront cost to be a construction company could be $10 million. And so the barrier to entry is $10 million. So if you don't have $10 million or someone won't loan you that $10 million, you're not going to be in a construction company. Likewise, with the cloud, in the old days, there'd be a similar calculation, but now you just need to be able to afford, let's say, $1,000 per month because it's a variable cost. Also, you can pay as needed. So you can ramp up, again, the servers, add 16 more cores, and then you can ramp it down when you don't need them anymore. And again, let's use that same construction analogy. You can't just go in and once you've bought a very expensive tractor, you can't go put it back to the store and say, look, I don't need this tractor anymore. So there are some real severe limitations when you have physical hardware that goes away by using the cloud. Another thing to talk about is the different types of models of cloud services. So there's software as a service, which we'll get into in a second. There is platform as a service. There is infrastructure as a service. There's metal as a service, and there's serverless. And all of these are different types of cloud computing service models, and we're going to get into each one of those. So to start with, let's talk about software as a service. This is probably one of the most familiar types of cloud services that you probably use right now. So what it means is that you can rent software through a subscription versus purchasing the software. And a few different examples of this would be we've got Gmail, right? If you're actually using Gmail, you may have even had to recently pay for Gmail because it's using a lot of storage. Other examples of that could be Dropbox is another one. You could also purchase for a service for Spotify, for example. These are all software as a service vendors that you're renting basically the software. You're not purchasing the software. And typically those software as a service companies are actually running on the cloud. And so let's say Spotify or Pandora or whatever company it is, they're typically building some kind of a business logic layer, and then you're paying a subscription to use that layer, and it's actually using the cloud. So even though it's a separate model, it again ties back to the cloud. Another one is platform as a service. And if you're not an active software engineer, this one may be less familiar to you, but let's talk about a couple examples on AWS. What this does is it allows you to focus on code versus on the infrastructure. A couple of examples that are very different on AWS are Elastic Beanstalk and Amazon SageMaker. So let's talk about Elastic Beanstalk real quick. What this does is it allows you to focus on building let's say a Flask app, right? A very small application, and you just focus on the logic. So you build something maybe that has an API or does some kind of purchasing function or some kind of business logic, and then you distribute that app to Beanstalk, and then Amazon does all the work of deploying it, maintaining it, and so it's abstracted at a high enough layer that you don't have to worry about it. It is the same as Amazon SageMaker. This is going to be a machine learning platform as a service, and what this does is it allows you to focus on building machine learning models, not focusing on the infrastructure, because SageMaker has the ability to spin up endpoints, and it also has the ability to distribute training jobs. And so what this means is that you, as the machine learning expert, you can focus on machine learning and not focus on maintaining the infrastructure. And so this is really one of the advantages of platform as a service. Other cloud providers have this as well. A good example that's been around for quite some time is called Google App Engine. And Google App Engine allows you to focus on building web-based applications, and then it will scale up and scale down automatically. Another type of service that's the most common on AWS is called infrastructure as a service. And what that does is it allows you to rent the building blocks. And so it could be things like storage, right? Here's a bunch of storage examples. With Amazon S3, this has 9 nines of uptime. So what this means is, only let's say a couple seconds per year, this is going to experience downtime. And so you can leverage something that has that great of characteristic by renting it versus building that yourself. So if you had to build something with 9 nines reliability, it may not be possible for, let's say, 5 years. It would take quite a long time to get all of that built, hire the correct people, have that level of expertise. But with Amazon, you can just rent it, and now you have this, highly scalable and very reliable object storage system. Same with the Elastic Block Storage. This is storage for that you attach to a EC2 instance. That has a lot of scalability characteristics that would be very complicated to build yourself. And then Elastic File System, this is hosted NFS. So these are all components that you can rent. And this is just storage, but they also have, EC2 for compute, and then, VPS or VPC. They have virtual private clouds where you can rent the networking as well. So these are just individual components like CPU, disk, and network, and they're all available for you to rent, the building blocks. Another one that's been around for a bit is Metal as a Service. And Amazon does have examples of this. And one example is Amazon M5 Metal. And what this does is it allows you to use all of the same technology that you would use for a virtualized instance, but you can control physical instances. And so some use cases for this would be, maybe advanced deep learning workflow. Let's say you have a physical hardware problem. You really need all of the capabilities of the physical hardware. You don't want to lose anything by virtualizing it, and so you want to rent these highly available, very very high end physical hardware, and so you can get the most performance out of it. Other examples would be maybe you need to have physical access to the machine via a terminal so that you can measure and instrument things at that layer, not have an abstraction in between. So these are also things that are available, but you can still use the cloud paradigms with this physical hardware, and that's really the advantage of this Metal as a Service. A newer one that's been very popular is serverless, and especially for data science, machine learning, newer types of workflows, serverless has become a really big deal. Another way of referring to serverless is to call it function as a service. And the reason you would call it function as a service is literally you have a function. Let's just make one real quick. We'll call it func, and you could return, let's say, x plus 1, and then this function takes x, and that's it. You could literally take something that's a couple lines of code, abstract it, put it into the cloud somewhere, and run it. And then that's the only thing you need to worry about. And so then you could attach that function, like this Lambda function right here, you could attach it to an event. So you could say, every time I put something into S3 storage, I want to call this function right here, and then it's attached via an event. And so this is probably one of the purest layers of abstraction, because as a developer or a machine learning person or a data analyst, you can focus on just the logic, just like you do with, let's say, Jupyter Notebook, and you can actually not worry about the infrastructure. Let's talk about some cloud deployment models next here. A lot of times you'll hear about the cloud, and that's really the cloud native type of deployment strategy, and that's you're building things in the cloud from day one. You're using all the cloud paradigms like serverless or elastic scaling. You're doing all those types of things. There's multi-cloud, which stands for having the ability to use many different types of clouds at the same time. So using, let's say, AWS and GCP and Azure, and distributing the workloads depending on which one is going to give you the best deal, right? So maybe you have credits for all three of those vendors, or you have spot pricing for Amazon, and you decide when you want to run a workload on which machine. Now, there's also hybrid. And what hybrid is you have some workloads in your own physical data center, and then you have some workloads that go into the cloud. And this is pretty common right now, is that many companies still haven't completely transitioned to the cloud. And so what that means is that in some cases, they're not actually going through and using all the raw characteristics. Now, another one to be aware of, again, is this cloud versus physical data center demand here, is that when you're dealing with your own data center, one of the problems that comes up is that you may have purchased a specific type of capacity here, and let's just say that, here's my my demand, but then this is my capacity over here. What happens is that you can get into these problems where you're basically over, so you have more demand, and we'll call this demand up here. You have more demand than you'd like, but you actually you have more capacity at the very beginning, or the opposite is you have, in fact, more demand and your capacity is actually not good enough, right? And so you get into these problems where you either have too many or you have too little servers. But with the AWS cloud, if you do that same thing, if we say demand over here and we have capacity over here, you can more evenly distribute it because the demand will actually be eliminated. Let's go into, let's look at some Amazon Web Services next here. Amazon Web Services are a application programming interface, or API, that exposes dozens and hundreds of services. And so an example here would be that with the Amazon cloud, you're able to actually access storage, compute, things like that, and you're able to just use let's say a command line tool or a web interface or an SDK, and you get access to everything that Amazon develops one by one. Some of the products that Amazon offers here are everything from analytics to application integration to AR, VR, cost management, business productivity, compute, customer engagement, databases, streaming, developer tools, game development, IoT, machine learning, migration, mobile services, storage, right? So there's a huge section of categories of services that if you were developing on your own, it would be really difficult for your company to provide. And especially at the level that Amazon provides them at. Now, if we talk about the core services of AWS, these are probably the most important ones to master, especially in the context of a cloud practitioner exam. First, you have compute. And in the compute space here, you've got Amazon EC2, and that stands for the virtualized computers, Windows, Linux, etc. Amazon ECR, this stands for the Amazon Container Registry. ECS stands for Elastic Container Service. EKS is Elastic Kubernetes Service. Lightsail is a hosted web service. So this is things like you could run a WordPress instance. AWS Batch is a service that allows you to run batch-based jobs. So you could, let's say, do a bunch of k-means clustering if you're a data science person. And then Beanstalk is the automated Flask or Java or Go-based web service hosting. And then Fargate is a managed container service. So you can run a container, which is a smaller type of unit than a virtualization, and you can run a task through Fargate. In terms of networking, you have VPCs, which create these firewalled environments. You have API gateways, which are APIs that you can attach functions to. CloudFront is a CDN. Private link, you have Route 53, which is DNS. You have Direct Connect, which you can connect your data center to Amazon's. In terms of storage, you have S3, which is object storage. EBS, Elastic Block Storage, is storage you attach to an instance. The Elastic File System is network mounted storage. And then with Glacier, this is a archival system. Snowball is the ability to take huge quantities of data, terabytes or petabytes of data, and move it into Amazon. Snowball Edge is the ability to do this at the edge. And then some of these other capabilities here are more specialized, like Snowmobile. You can literally take a truck full of data and move it into Amazon. Now, in terms of database, Amazon Aurora is a MySQL and Postgres compatible clustered database solution. DynamoDB is a key value based database system. It also has backwards compatibility with Mongo. Elasticache is a caching system, and then Neptune is a graph database. So as you can see, these core services are enough just by themselves, and there's many more services to build literally anything you could possibly think of on the AWS cloud.